10 million bamboo poles form the hidden foundation of the Semarang-Demak Expressway in Indonesia. This massive quantity of organic material replaces the traditional exclusive reliance on steel and concrete structures. The project stands as the first in the world to utilize such a technique on this scale to stabilize the ground. Engineers faced a critical challenge due to the route's location directly adjacent to the Java Sea. But this is just the beginning. Why did the builders choose simple bamboo over modern industrial composites? The soil in this coastal region is notoriously weak and unstable. Bamboo serves as a natural, sustainable, and cost-effective solution to reinforce this shifting earth without the immense weight of standard foundations. More than 1,500 skilled workers directly participated in the installation process. One can notice how they layer the poles into a massive mat system beneath the roadbed. At first glance, laying vegetation seems like a primitive method, but in reality, it creates a flexible matrix capable of supporting heavy traffic loads. The mats distribute weight evenly across the soft terrain. It gets more complex further on. It is visible how the grid structure locks into the soil to prevent sinking. This approach allows the highway to traverse an area once considered extremely challenging for construction. The bamboo effectively solidifies the base where heavy concrete might fail. The road surface is now ready to withstand the passage of vehicles. Tens of millions of cubic meters of water surge across the northern coastal area of Java Island within just a few hours. Dozens of floods strike the region every year. The Semarang-Demak project serves transportation and defense. But this is just the beginning. Therefore, it acts as a natural sea barrier protecting thousands of households from the risk of flooding. The entire route spans 26.95 kilometers to cover the affected zone. It splits into Semarang Sayang at 10.64 kilometers and Sayang Demak at 16.31 kilometers. But such scale requires a total investment of 16.8 trillion rupiah. The Sayang Demak section was officially opened in February 2023. The Semarang Sayang segment remains under construction until early 2027. One can notice the bamboo mat system being implemented there. Transition to the next level. Why is the bamboo mat chosen? At first glance, it seems simple. But in reality, compared to other ground stabilization technologies, it is the most cost-effective solution. The material provides a durable and environmentally friendly structure. As a natural resource, bamboo causes no pollution. It is visible how it allows ship operations without affecting the marine ecosystem. And this is not the limit. Indonesia possesses up to 162 species of bamboo out of 1,439 worldwide. This abundant supply ensures the large-scale infrastructure project operates sustainably for many decades to come. The system is ready for the future. 3 years is the mandatory age for any bamboo pole intended for use. The selection process is rigorous. Only stalks with a minimum diameter of 10 centimeters qualify. A straight length of at least 8 meters is also required to meet the standards. Why are strict testing procedures necessary? Mere appearance cannot guarantee mechanical strength. Validation ensures long-term stability under the influence of seawater. At first glance, the poles seem ready, but they must prove their worth. Engineers apply 2 common tests to the material. The transverse tension test measures torsional and tensile strength. But this is just the beginning. One can notice the deflection during the perpendicular bending test to evaluate elasticity. This confirms the ability to recover after deformation. The bamboo is now ready for the next phase. 7 bamboo poles are tightly bound together to form a single structural pile. After inspection, the qualified material arrives to support a highway built over the sea. Why use bamboo here? At first glance, it seems simple, but in reality, driven vertically into soft ground, it functions like a stable stake. One can notice piles driven at intervals of about 1 meter, but this is just the beginning. The foundation base extends up to 150 meters wide. It is visible how poles are arranged and tied into rafts. These are installed by laying them directly on the vertical supports. Ropes fasten the piles to the rafts at each end. The equipment gradually aligns the mat with the original design. It gets more complex further on. The assembly sinks slowly. It becomes part of the coral reef, reinforcing the underwater structure. 150 meters of width are covered in the next phase. Geotextile fabric is laid to reinforce the underwater structure. It is visible how the material spreads evenly across the area. Why is this synthetic barrier required here? The bamboo matting contains natural spaces. One can notice how the fabric acts as a separating membrane, preventing sand from seeping into the gaps between the bamboo mats. At first glance, it seems simple, but in reality, it distributes the load and stabilizes the surface before the next material is added. But this is just the beginning. Sections are continuously connected to create a uniform and durable technical cushion for the subsequent layer. 6,000 meters. Exactly the distance the bamboo raft and sand foundation extends along the highway. This massive structure creates a uniform and durable technical cushion. After the geotextile fabric layer is completely secured, the stage begins with the arrival of massive sand dredging vessels off the coast of Java. But this is just the beginning. Why is the trailing suction hopper dredger indispensable for this specific task? It seems that standard ships could haul the load. This specialized vessel uses suction pipes located beneath its hull to reach the seabed, extract sand, and store it in onboard hoppers. One can notice how high-capacity dredger ships pump sea sand over the entire bamboo mat system. At first glance, spraying material seems simple, but in reality, the sand is ejected through a special conduit to cover an area of more than 150 meters. This process is repeated continuously. The result is a structure that is both highly load-bearing and flexible enough to adapt to the rough marine terrain. And this is not the limit. Layering proceeds methodically to ensure maximum stability. One layer of bamboo alternates with one layer of sand until reaching the 17th layer. It is visible how this creates a solid foundation equivalent to 6 kilometers. The construction phase concludes here calmly. Vertical strips of drainage material are inserted to stabilize the terrain. Engineers use them to shorten the consolidation time of the soft soil foundation. One can notice how they function like conduits, but this is just the beginning. Why is drainage critical here? Moisture slows down settling. Drains allow water within pores to escape to the surface instead of being trapped inside. At first glance, the sand layer above seems static, but in reality, it exerts compression pressure. Water is forced upward along the drains and discharged. This enables the soil foundation to stabilize rapidly. Consequently, the consolidation rate increases several times. The project reaches the required settlement level in a much shorter time, ready for the road surface construction phase. The base is prepared. 4 distinct overlapping layers form the foundation system of this roadway. From this point onward, the construction process proceeds similarly to conventional expressways. Why is the standard subgrade replaced in this specific project? The usual method relies on compacted natural soil, but here, alternating layers of bamboo and sand act as the main load-bearing foundation. But this is just the beginning. The structure rises level by level. One can notice how the sub-base course is laid immediately above the bamboo foundation. This layer consists of crushed stone designed to increase load capacity. It seems like a simple deposit of rock, but in reality, it prevents the underlying soil from being pushed upward. Above the stone lies the base course composed of granular material or a bituminous mixture. This layer helps evenly distribute pressure from the road surface to the layers beneath. It does not end at this stage. The surface course follows as the final element made of a mixture of bitumen and mineral aggregates. This layer remains directly in contact with vehicles, ensuring a smooth, durable, and wear-resistant pavement. The road surface is now fully prepared for operation. 9,000 skyscrapers rise from the foundation of Hong Kong, creating a vertical forest of steel and concrete that dwarfs other global capitals. This city possesses nearly twice as many high-rise buildings as New York and 3 times as many as Shanghai. Yet, amidst this ultra-modern urban landscape, one can notice the organic texture of bamboo scaffolding wrapping the exteriors of glass towers. While the rest of the world relies heavily on metal frameworks, this region remains fiercely loyal to a construction technique with a history spanning hundreds of years. From highways over the Java Sea to these summits, the material evolves from a humble plant into a structural pillar. But this is just the beginning of the paradox. Why does a futuristic financial hub trust its skyline to temporary grass structures? It would seem that manufactured steel pipes offer more consistency than nature for such heights. The answer lies in the rigorous preparation that turns raw poles into engineering components. Before arriving at the concrete jungle, the material goes through a meticulous selection process where only the finest specimens qualify. Bamboo must be between 3 and 5 years old to ensure it has matured enough for industrial use. Workers air dry the selected poles for at least 3 months to eliminate moisture and achieve maximum mechanical strength. This treatment is the key factor that determines the overall safety of the entire scaffolding structure. Only after passing this strict inspection do the qualified poles begin their new journey to the construction sites. There, they form an intricate lattice stretching from the street level to the clouds. It is visible how the framework adapts, becoming both lightweight and incredibly strong when assembled with precision. Everything only gets more complicated. Each pole serves a limited life cycle, being reused up to 3 times before warping or losing its essential flexibility. One can notice how the scaffolders manually tie every joint using nylon knots, a skill that requires years of dedicated practice to master. 2 distinct types of bamboo are commonly utilized to balance the load. Thick moso bamboo is installed for the heavy load-bearing sections, while the smaller, lighter guadua or gold duke bamboo handles the frame connections. Thanks to this inherent pliability, the scaffolding can wrap around balconies, curved facades, and even suspended architectural structures where rigid metal would fail. In certain areas, metal supports are added to the matrix to strictly increase stability. At first glance, the woven exterior looks like a simple rustic mesh, but in reality, it is a complex safety system demanding absolute focus. Although durable, the material is not uniform in size or shape, forcing builders to adjust constantly. Even the smallest mistake in a knot can affect the integrity of the entire structure. And this is not the limit of the requirements. While in the past, workers climbed dozens of stories without protective equipment, today, Hong Kong law mandates the use of safety harnesses, helmets, gloves, and non-slip shoes. The demanding nature of these techniques and a lack of skilled successors have caused the art to gradually disappear in many regions. However, in this city, the green material is still celebrated as a vital symbol of craftsmanship. The bamboo holds its ground, serving as a unique badge of Asian identity. Greater tensile strength than steel, this is the defining technical characteristic of bamboo. Why is it regarded as the green material of the 21st century? At first glance, comparing a plant to metal seems disproportionate. However, due to rapid renewability, bamboo withstands high loads while remaining lightweight, flexible, and easy to work with. But this is just the beginning. Steel production generates a massive amount of greenhouse gas emissions. This process requires burning large quantities of fossil fuels, including coal and oil. One can notice how dense industrial smoke rises, signaling the environmental cost of metal. Not every country has the capability to develop a large-scale steel industry. This increases costs and environmental impact globally. In contrast, bamboo offers a different path: locally sourced, low cost, and highly sustainable. It gets more complex further on. In tropical regions, the plant grows quickly and requires minimal maintenance. It is visible how easy it is to cultivate these forests. Therefore, bamboo serves not only as a building material, but also as a symbol of sustainable architecture for the future. Architecture for the future is increasingly built upon the strong longitudinal fiber structure of bamboo. Today, this versatile plant is not only used in heavy construction, but has also become an environmentally friendly material for a wide range of consumer products such as straws, chopsticks, toothbrushes, cups, spoons, baskets, and decorative items. Its lightweight nature and natural moisture resistance allow it to effectively replace plastic, a material that has caused severe global pollution. But this is just the beginning. Why is the transition to bamboo products considered vital for the environment? The impact of a single item might seem negligible to the naked eye. However, each bamboo straw or pair of bamboo chopsticks plays a vital role in reducing single-use plastic waste and promoting a greener lifestyle. At first glance, the production process seems simple, but in reality, it guarantees safety and durability through specific steps. The raw material is cut, boiled, and thoroughly dried, then polished to a smooth finish. One can notice how the items are treated for antibacterial protection using natural methods such as steaming or soaking in bamboo vinegar. As a result, the products are safe for human health and fully biodegradable after disposal. It gets more complex further on. Many small workshops have grown into sustainable production chains. Therefore, these enterprises create jobs for local communities, making bamboo a symbol of the green circular economy connecting nature, people, and the future. Everything can be utilized, with different groups taking charge of each stage. A portion of bamboo waste is used to produce bamboo charcoal. One can observe how this charcoal is used in cars or rooms for deodorization due to its excellent odor-absorbing properties, or even for water filtration. And this is not the limit. During the production of bamboo charcoal, a byproduct known as bamboo wood vinegar is created. It is visible how this liquid is collected for use in medicine or as a natural termite repellent. The organic material is fully processed without leaving harmful residues. Zero synthetic chemicals allow the stalk to act as a natural termite repellent. Historically, builders saw it as a humble material suited only for thatched roofs and small village bridges. At first glance, the hollow stems seem too weak for heavy industry, but in reality, their structure possesses a tensile strength that rivals modern alloys. It appears to be a simple grass, but this is just the beginning. Why does this organic material now compete with complex machinery? The reason is not visible on the green surface. The answer lies in the density of the fibers, which humankind has redefined for structural applications. The miracle involves physical properties that turn the plant into a load-bearing unit. One can notice bamboo bundles forming foundations for roads stretching out to sea. Scaffolding made of these poles rises dozens of stories to support skyscrapers in modern cities. The camera glides along the vertical frames, revealing how the organic grid holds weight. Transition to the next level. It stands as a functional alternative to steel. Because true innovation often comes from observing familiar objects in a new light. Therefore, flexible adaptability proves the stalk is not just cultural heritage. It serves as a sustainable material of the future, meeting the demands of the industrial world with respect for nature. The application of the material continues its steady path,